Okay, I'm just going to go through question 2 from page 284. So this is obviously a past paper question and it's using specific heat capacity as the learning objective. So the first part, so the question's about a room and a heater, a gas heater in a room. And in the question, they tell us the volume of the room, so therefore we know the volume of the air. It tells us the temperature change and it tells us the density. So whenever you see density in the details, immediately that should be triggering the fact that if you're being told the density, then at some point you're going to have to use a formula that density is the mass divided by the volume. It's almost a given. So as soon as you see the word density, maybe write that formula down somewhere in the margin because you're likely to have to use it later on. Okay, so the first question is calculate the energy required to raise the temperature of the air, and they give you the specific heat capacity of air of 990 joules per kilogram Kelvin. Okay, so first thing then, to work out the specific heat capacity, we need to know the mass of the air. So the mass of the air is going to be, using this formula, is going to be density times the volume. Okay, so density we're told is 1.3. The volume I've just worked out by just doing length, breadth, width, which that's 43.2. So that's going to be 56.16 kilograms of air. So now we know the mass, we're just going to use specific heat capacity. So the change in energy is mass times the heat capacity of air times the change in temperature. So you just substitute all that in. So 56.16 times 990 times by 9. That's the change in temperature. And that gives us approximately 0.5 megajoules. That's your answer. That's part A. Part B, the heater has an output power of 2.3 kilowatts. So power equals 2.3 kilowatts. And again, just like density, as soon as you're given the word power in a question, you should be thinking that power is energy divided by time. At some point, you're probably going to have to need to use this as part of the problem. Okay. They also tell you that each cubic metre of heating gas provides 39 megajoules of energy. Okay, so the first thing is they're asking us to work out the time the heater has to be on for to change the temperature. So therefore, obviously, we're going to have to use our power formula. So power is energy divided by time. So the time is energy divided by the power. We've already worked out the energy in the first part of the question, so 0.5 megajoules, so times 10 to the 6 joules, divided by 2.3 kilowatts or 2,300 regular watts. So that's 217 seconds. So you've got the time. Part 2. Now they're wanting us to give us the mass of the heating gas used in this time. Okay. So we're told that first thing to do is to find the volume. So the volume of gas used is going to give the total energy required. So that's going to be 0.5 times 10 to the 6. That's how much energy we need. And in the question, we're told that each metre cubed of heating gas provides 39 megajoules. So we're going to find out how many metres cubed we need. So 39 megajoules, 39 times 10 to the 6. And that gives us 0.013 metre cubed of gas. So that's given us the volume of the gas. We want the mass. So just like in the first part of the question, we're told the density of the gas. So it's basically we're going to have to use our old friend the density equation again, aren't we? So mass of gas equals the density multiplied by the volume. The density of gas we're given in the question, which is 0.72 kilograms per metre cubed. The volume was 0.013. So that means the mass of the gas we need to use is going to be 9.2 times 10 to the minus 3 kilograms. That's the answer. Part C is a descriptive question. Why? 2 reasons why the time required to and the mass of the gas is going to be more than we've just calculated. So a sensible suggestion. So for example, in the room, it's not going to be airtight. So therefore there's going to be hot air escaping from the room, under the doors, through drafts, through the windows, that kind of thing. Also, you could say that the room isn't going to be empty. So you're going to have to also heat the contents of the room, like the furniture and the walls and the floor. So there's more to be heated than just the air in the room. Both of those things are going to contribute to needing more gas than we've just calculated.